All right, welcome everyone to our October 2020 virtual star party. I'm Jim Knoll. I am the star party manager for the Tucson Amateur Astronomy Association. We've been doing these virtual star parties about every other month since I think it was April when we started. And so we've learned a lot getting them streamed out to everyone. And so hopefully this one will go well as well. We have 4 TAAA, we call Tucson Amateur Astronomy Association, TAAA. We have 4 members on tonight. Myself, Jim O'Connor here in Tucson with a telescope, and we'll show the telescope slides with when we go around and talk about the various astronomers. Bernie Stinger, who's actually up in Minnesota right now, and then Rick Paul here in Tucson. What we're going to focus on tonight, because we have kind of a unique situation, is we have a lot of planets and solar system objects that are available. So what we'll do is we're going to focus on Jupiter, Saturn, Pluto even, the moon. We'll do Mars, Neptune, and Uranus. So it'll be kind of cool. We're going to hit just about all of them. The only ones we won't be able to do are Mercury and Venus. Due to weather being potentially a problem here in Tucson, but more so probably in Minnesota this time of year, we did choose to record the actual telescope views in advance. But we will be on the chat for both Facebook as well as YouTube to answer any questions and provide any kind of explanation as we're going through. So we're going to encourage you to let us know on the chat where you're from, maybe your name and your first name and where you're observing from. And then as we go along, if you have any questions, let us know, and we won't be able to answer them live, and we won't be able to adjust what we're looking at, but we will be able to answer your questions on the chat. So a little bit about the club. The Tucson Amateur Astronomy Association has about 400 members. And before COVID started, so in 2019, we actually averaged about 225 events, in-person astronomy events. So about half of those were for schools. We also did public star parties, nonprofit organizations, youth groups, resorts. And so we had a pretty good variety. And Tucson is kind of known for its fairly good dark skies. And so we can even do some of these events in downtown Tucson. But since mid-March, we pretty well stopped doing in-person events. We are going to try to get some smaller events going when we can, but most of it will remain virtual probably through the end of the year. So what we'll do now is, like I said, we've got 2 telescopes that we're going to be looking through tonight, Bernie Stinger and Jim O'Connor. And we'll also show, like Pluto, we're going to show some images and maybe some of the other planets, depending upon what kind of view we get through the telescope. Because unfortunately with telescopes and cameras, you're kind of at the mercy, not only of having clear skies, but having good seeing, which we talk about, if you look at like the moon through a pair of binoculars, and you can see kind of the wavy lines going through there, that is an indication that there's a lot of seeing issues. So, and that's happening tonight here in Tucson. So we'll see how things shake out, but we'll do our best to show you what we're doing and talk a little bit about it. And what we'll do, before we take a look at any of the telescope views, I'll show some where things are in the night sky with a planetarium program. And the program primarily that we're going to be using is a program called Stellarium, and it's a free program. It's good for PCs and Macs. You can go to stellarium.org and download it and configure it. And it's a good way to kind of learn the night sky. There's also a lot of really great phone apps out there that'll help you look at the night sky in live. Let us know if you do have any questions on the chat, and we'll go from there. A couple of reasons that we really want to focus on the solar system. Not only are a lot of them visible, but we have 2 really cool events happening this month. On October 13th, Mars will be at opposition. So I'll show you what that looks like in the planetarium program and talk a little bit about that. And then at the end of the month, on the 31st, Uranus will be in opposition. So that means they're basically about the closest they can get with with the Earth. So that's a good time to try to look at them through the telescope. Plus, they're visible from basically sunset to sunrise. All right, so let's go ahead and take a look at our first object. So this is kind of the current orientation of where the planets are in our solar system right now, because any of the planets that are closer in to the sun orbit faster than those that are farther out. So the four inner planets are Mercury, Venus, Earth, and Mars. Now, if you look at Mars as compared to Earth, that's what we mean by opposition. It is basically opposite of the Earth from the sun. And it's generally about its closest in its orbit because both orbits are very close to each other. If we zoom further out, then you can start seeing Jupiter. And the big gap in between Jupiter and Mars, there's an asteroid belt. So that's where some of the leftover asteroids in our solar system are at. And Jupiter does a pretty good job because Jupiter is the largest planet in our solar system. It does a pretty good job of managing the asteroid belt by keeping the asteroids out there and not barreling in towards the Earth. And then the next planet out is Saturn. And then we go to Uranus, Neptune, and then little old Pluto way out there. So you can see that it's quite a distance out to Pluto. And if you look at the plane of the planets, let's see if I can. So there's kind of the plane of the planets. Most of them orbit right around in the same plane as the Earth and the Sun. But Pluto, it does have a different orbit and it's much more elliptical. And they think that, and that's one reason why Pluto was demoted, because they think that it's actually one of the closest and probably the largest, at least what we've seen so far, in a belt of objects called the Kuiper belt, which is out here beyond Pluto. So it's way out here. And then beyond the Kuiper belt, we have what's called the Oort cloud, which is a big spherical cloud of, comets. There's comets in both the Kuiper belt and the Oort cloud. Some of the shorter comets that will come in, in the span of maybe every 85 to 100 years, probably originate from the Kuiper belt. The ones that come in that maybe only come in every 1,000 years or sometimes even longer, probably come in from the Oort cloud. So it's way out there. All right. So now what we're going to do is we are going to start with looking at some planets. So the first group we're going to look at is Saturn and Jupiter. So if you look kind of down towards the southern sky, just zoom out just a little bit more, down in that direction. Sometimes if you've got some good skies, you can actually see what we call the teapot, which is Sagittarius. So you can kind of see the handle here. This is the main part of the teapot. This is the top part, and then this is the spout. And where the steam would be coming out of the spout is kind of in towards the center of our Milky Way galaxy. So both Jupiter and Saturn are kind of hanging out in that general area. And if we zoom in, we can actually see that there's another one right in between them, Pluto. So we got three planets pretty much in the same general area of Saturn, of the southwest. So we're going to take a look at Jupiter to start with. Jupiter is the largest planet in our solar system. So it's so large, of all the material in our matter in our solar system, the sun makes up 99.8% of all the matter in our solar system. Jupiter makes up 0.1% of what's left over of the 0.2, and everybody else makes up the 0.1. So all the other planets, asteroids, comets, all the other little stuff that's still around here makes up the rest of it. So Jupiter's big. You can actually put 1,300 Earths inside the sphere of Jupiter. And you'll see it shows up pretty well in a telescope. It also has, Jupiter and Saturn have the most moons. Jupiter has 79. And of Jupiter's 4 moons that we can see through amateur telescopes, 3 of the 4 are larger than our moon, and its largest moon is larger than Mercury. So they're pretty good size. Now Jupiter and Saturn also have some very small, probably asteroids that get caught up. Basically, anything that gets close to Jupiter either kind of becomes part of its system, or it might get flung out and get flung out of the solar system, or potentially flung into the inner solar system, which would not be very good. All right, so what we're going to do now is we're going to switch over to Jim's telescope, and I'm going to let him show first his telescope setup, and then we'll take a look at what he's got in his scope.
Right there is the daytime view of the setup I'm working from. I'm sitting at that table, staring at the laptop in the picture on the left, and in front of me is my telescope setup. The telescope itself, the optical tube, is a 10-inch Schmidt-Cassegrain style telescope. It's on a Celestron AVX tripod and mount head, and it's a good size to use for going around and working at schools and showing some pretty good images. You can see to the left of that tripod is a monitor. That monitor allows me to see things that aren't going out of the telescope on broadcast and sort of do a fine tuning. It's sort of like a monitor up on a stage at a rock concert. So I've got on that table you see there's a laptop sitting there, and there's a bunch of equipment look like plugged into the side of the computer. That cords that are coming in there are bringing one channel of video from the camera. And that means we can shift over to the right picture and look at that camera that's in there instead of an eyepiece. That camera is a Malin cam called an exterminator. The exterminator has got the highest sensitive CCD that was made and is no longer being made, so it's a good heirloom to hang on to. The camera itself has two video outputs. One is a channel called S video, and that's what you're seeing this when we get to see Jupiter. That's what you'll be seeing it on. The other is typical composite video, and that is what's going over to the monitor that's off on the side. So I can keep my eye on it all the time, no matter what's going out on the laptop, as far as the rest of the conversations. That camera, if you can take a look at it, it's got some junk hanging on it. That is a thermoelectric cooler, and it acts like a heat sink. And it's got two big fans that are blowing on it to keep the heat of the video chip that's in there, to try to keep that heat down, because the chips don't like the heat. They can delaminate if they have too many heat cycles. So you try to keep the heat down. The usual optimum temperature to have is 0 degrees centigrade, even though my cooler can go down as low as minus 20 degrees centigrade. But right now I have the cooler only blowing fan air on it because it's a cool night and I'm not doing very much heavy work on the camera. And that's about it on the telescope. It's a pretty easy setup to operate, except I have to walk over and go over and change a focus every time things change, because I am really in the 19th century almost on how telescopes operate, except for the camera. All right, what you see is Jupiter through our, as Jim said, our rather turbulent atmosphere tonight, although I have been able to get the weather bands in. The fat dark ones in the middle are called the North and South Equatorial Belt. And it's in the, it's actually an upside down version. And when we're lucky enough to have a great red spot, it would be in that middle of that black, the top belt. And down below it are thinner and smaller lines. What those are temperature indicators. Jupiter is pretty windy, sometimes up to 300 miles an hour or more. In the atmosphere. And as a result, what happens is the atmosphere comes up and goes down. Space cools off some of that air. So the bright bars you see, the bright bands you see on Jupiter are the hot bands coming up from the planet. The dark bands are the cooled off air going back down to the planet. And right now I'm going to let you notice you don't see any moons. That's because your human eye is a whole lot better at adapting to changes in brightness, but cameras only sit at one spot. So right now I'm at 1/2000th of a second. I'm going to change it to 1/30th of a second and see if the moons can drop out. And right now that ALC that I just selected is the level control, and I'm at 1/2000th of a second. So let's see if I can get down to 0. Now you see the moons dropping, showing up there on the right-hand side, because that happens to be where they all are tonight. Now, the problem is I'm going to move it a little bit. I'm going to move Jupiter to the upper corner. And the reason I'm going to do that is all 3 moons that we can see tonight are on the right-hand side of the view there. I'm trying to go farther out and see if I can get the last moon out. Been bashful tonight at times. Well, out off the edge of that screen, yeah, it hasn't, it's decided to get a little bashful. The 2 you're seeing right there are Io and Europa. The furthest out one that's right off the lower right corner is Callisto. It's now reaching its outer part of the orbit, and I'm just at too high a power right now to get the field of view small enough. I can do a quick fix of that and go and let's see if we can find Callisto. Not sure if we can. Turn the zoom off. There's Callisto. Let me get this off. And save this. There's Callisto, how far out it is. But what I just did is change from 320 power to 160 power. I'm going back to 320 so we can look at some more interesting things here. And that just says turn the zoom on. And with the electronics involved with trying to broadcast and show, it's really slow. I'm hitting the buttons as fast as I can, but not being so lucky. So I'm going to go change the speed now, the shutter speed now to 1/2000th of a second and see if we can get it back. Now, why aren't we seeing the 4th moon? Well, if you take a look at Jupiter, you can't see it because it's right in the middle. It's right in the middle, and the camera is adjusted to the brightness of Jupiter, and we're not picking up Ganymede. Ganymede's the largest moon, and it's hiding right in the face of Jupiter. Let me try to get that back down. Jupiter, Jove, that is actually responsible, that object is responsible for the structure of the solar system. It was always a puzzle as we started discovering exoplanets that why are all the gas giants for the exoplanets closer than the orbit of Mercury is for our sun? In our case, the gas giants are all on the outer outskirts of the solar system. And the reason is that when it is now being discovered that as the solar system formed with the simulations we're doing, Jupiter actually was closer than Mercury to the sun. And so were the other gas giants that were forming, Saturn, Neptune, and Uranus. Well, what happened was this is a population 1 star that we're circulating. And that means it's the newest generation. The oldest stars are population 3. This is population 1. So as a result, population 1 has the benefit of all the debris from all the other supernovas. So we had a very rocky cloud we formed out of. Well, Jupiter was in there, but most of the rocks were further out, and that mass started pulling the gas giants out. As a result, there were as many as 20 to 30 inner planets that Jupiter, because of its mass, caused to collide with each other. We can find proof of this if we look at the upper surface of the sun, where we see an element called iridium. That iridium is the leftover of destroyed planets. In fact, the Earth is a 2nd generation planet. It formed after those first 20 or 30 were destroyed. Mars was never affected. It was too far out. But if you look at Mercury, Venus, and Earth, they're all 2nd generation in that place that Jupiter cleared out as it sailed out to its position now. That's called the grand, used to be called the grand tack model. It's now called the grand attack model because Jupiter causing the demise of all those objects. And at the time, it was moving out there at about 3.5 billion years ago. When Jupiter got into the position it was in, as Jim was saying, the asteroids were all hanging out there. The asteroids actually got affected by the presence of Jupiter and Saturn. Their weight, their mass actually slowed down the orbits of the asteroids as they passed. And when it slowed them down as they passed those planets, they actually lost their orbital energy and came in and pummeled the moon and Mercury and Earth. Earth is the only planet with atmosphere left anymore, and it kind of smoothed that out. But Jupiter was the reason for what was called the late heavy bombardment 3.5 billion years ago that gave us the wonderful looking moon we've got. And that's pretty much Jupiter in a small nutshell.
All right. Well, thanks, Jim. That's a good overview. All right. Now what we're going to do is we're going to take a look at Bernie Stinger's setup and and Jupiter. Bernie right now, as I mentioned earlier, is located in Minnesota, and he's at his Minneapolis dark sky site. So Bernie, it's all yours.
Thank you, Jim. Again, I'm Bernie Stinger. I'm part of the Minnesota Astronomical Society as well as the Tucson group. And I'm right up in Minnesota right now. And I'd like to show you my setup. So here is a image of what my telescope looks like tonight. You'll see the telescope on the right there. This was taken about a half an hour ago before the sun set. It's dark now, but this is a Celestron 8-inch Schmidt-Cassegrain telescope with a Celestron mount, and on the back end is a Malincam 10 megapixel astronomical video camera, which I'll be using tonight to show you images of celestial objects. And then right in the middle there, you might see kind of a narrower section. There's a Barlow lens. That's for magnifying the image, because what we're looking at tonight will be very small objects that require a lot of magnification. So let's quickly shoot over and take a look. And right now I've got a magnified image of the planet Jupiter. Now you probably notice it's a little blurry. The sky conditions aren't the very best tonight, but as is typical when you look at planets, they kind of come and go. So you'll notice there's cloud bands going from lower left to upper right. There's two of them. Those are the equatorial cloud bands. You'll notice some little spots in there. Those are festoons. Those are cloud storms that are swirling and causing eddies in the cloud bands. And then you can just make out on what's called the top and the bottom of the planet. Sorry if it's on its side, but the top and the bottom of the planet showing the polar cloud bands as well. So that's an idea of what Jupiter looks like on a fairly good evening. Not the best, but not too bad. And then I'd like to increase the exposure time up a little bit. And I'm going to overexpose Jupiter, but by doing so, we bring out the moons of Jupiter. And now you can make them out. There's 4 of them. And I believe they are lined up. Let's take a quick look. Okay, so what you're seeing is Io, the closest one, Ganymede on the opposite side, and then Europa and Callisto out further. So this is Ganymede, Io, Europa, and Callisto in that order. And Io is getting very close to the surface of the planet. It's going to go behind the planet very shortly, probably in the next half an hour or so, and that'll wink out and not be visible for about an hour before it pops up on the other side.
And Saturn is the second largest planet in our solar system. Within Saturn, you can actually put 700 Earths inside that ball. So Saturn is pretty good sized. It is about 900, little over 900 million miles from us right now. So at the speed of light, if you look at the light that you're seeing in the telescope, at the speed of light, that is 82 light minutes old. So that's kind of cool. When we do astronomy, especially when we look at really far stuff, then we're actually looking back in time. And so you're almost doing time traveling without ever leaving Earth. Titan, Saturn's largest moon, which we'll look at here in just a minute in Jim's scope, is the second largest moon in our solar system. So, and Saturn actually has more moons, even though it's half the size of Jupiter, it has more moons than Jupiter. It's up to 82 now. So Saturn's got 82 and Jupiter's got 79. I'm sure as we put other spacecraft there that, every time they do a count, they find more objects there. And, anything that gets close to either of these two big planets usually becomes a moon or crashes into it.
All right, there's Saturn as the best we can get tonight, the best I can get with this camera tonight. And it is, you can see it wobble back and forth a little bit. And the reason for that is the turbulence in the upper atmosphere is shifting the image around. The planet Saturn is unusual because of the rings that are around it. And those rings that are around Saturn were first detected by Galileo around 1610, except he didn't have a good enough telescope to really see them as rings. He thought they were ears on the side of it. It wasn't for about another, maybe 30 years that people began to really get the ring shape out of it. The rings seem to be made up of a comet or two or more that got too close to Saturn and were broken up, and those are, or collisions of other moons that were around Saturn. In any event, they reflect so much light back to us that and the spectroscopy shows they're pretty much water ice. And that ice is only a kilometer thick. From that far away, they stand out so much and reflect so much sunlight back at us. So that's the important part of being Saturn. That and the fact that its specific gravity is less than 1, and therefore, if you found a big enough bathtub, it would actually float, but it would leave a ring. That's an astronomy joke. That's not what would really happen because of the temperatures involved. But Saturn's average temperature is about minus 110 degrees, but that's because of the coldness of space out to the outer side. In the center, its temperature is about 20,000 Fahrenheit, where the small solid center part is. Okay, what we have moved to is Saturn, and it's pretty grossly overexposed. It's sitting there right now at nearly a full second of exposure. And what we're seeing, all those dots around it, most of the dots around it, all but one, are moons. There are actually 8 Saturnian moons visible from the surface of the Earth. The higher you are in altitude, the easier they are to see. But right there, I've got 4 underneath the planet, 1 very high up above the planet, and there's one some of you might see at about a 45-degree angle off the planet. The other 2 dots you see are probably field stars, or they may be hot pixels, because I don't have the cooler on the camera because we are not doing any long duration. So sometimes there will be, this chip is allowed to have as many as 3 hot pixels on it. So that may be just phantoms in there. but hot pixels have a tendency of looking their color rather than as dim as the one in the lower left is. Okay, so those are the moons. It's very populous. They herd the rings. You know, the rings of Saturn have a lot of bands in them you may have heard about. Those rings are broken up ice that's floating around. It looks like a comet or more, one or more comets have broken up and coming in close to Saturn within the last few million, 100 million years. And it's only a kilometer thick. The rings are only about a kilometer thick, and but they want to migrate wherever gravity takes them. Well, those moons that you see, and there's a whole lot more that Jim will talk about, that there are moons around there, they're actually called herding moons. They actually use their own gravity as they penetrate into the rings to keep the rings in order, so they don't just all plummet eventually into the gases of Saturn.
Okay, so we've moved over to Saturn now. Saturn is coming through fairly good tonight. The rings are fairly clear. And if you look closely across the planet itself, I'll expand it out just a little bit more. Right across the planet itself, you can see kind of a dark band, and that's cloud bands on Saturn as well. Saturn, like Jupiter, also has cloud bands. They're a little more tenuous, they're a little harder to see, but they do pop in and out of view occasionally on a good day. Now, something else I'd like to try doing is showing you some of the moons. So I'm going to go to a longer exposure and see if we can get some of the moons to pop out. The moons of Saturn are quite faint. They aren't bright like the moons of Jupiter. So it does take a little more exposure to make them show up. And I'm going to increase the gain up here a little bit. Try that again. See if that helps. Okay, now I got some moons showing up. So these bright spots here are moons of Jupiter.
Okay, so those are the two big planets. Now we're going to take a look at little old Pluto. Now, if you remember when I was showing you in the planetarium program, Pluto was right in between Jupiter and Saturn. Now, I really wish we could see this view of Pluto through our telescopes, but we're going to show you in a minute what we can actually see on a good day through our telescopes. And it's pretty tiny. Pluto is very, very, very tiny. This picture was actually taken by the New Horizons spacecraft when it flew by in 2015. So you can see, some of the ices on the surface, a lot of the Potmore craters. So it's got a pretty well-defined surface. So Pluto is about magnitude plus 14. So we didn't talk about magnitudes yet, but a magnitude generally with dark skies and a nice pinpoint star, you can probably see a magnitude plus 6 with your naked eye. The higher the number, the dimmer the object. So a magnitude 14 visually takes a pretty large telescope. Now we're going to look at what Rick found in his telescope using a camera, because with all of these and a camera, you can gather a lot more light. And so that allows us to be able to see fainter things. But as you saw with Jupiter and Saturn, sometimes they will look even better in an eyepiece because the camera can also accentuate the seeing conditions and the blurriness and things like that. So this was taken with New Horizons, and it's right at the very beginning of the Kuiper Belt and the Oort cloud. So it's way out there. It is a little over 3 billion miles away from us right now. And if you remember the orbit I showed initially, it's got a fairly highly elliptical orbit. So and so it can get much, much further. So at 3 billion miles, that's 283 light minutes we're looking back in time. So when we look at Rick's scope, we'll be able to look back in time, see what that little dot looks like 283 minutes ago. So it varies between 30 and 48 astronomical units. It's about 33 right now, so it's still fairly close in its orbit. An astronomical unit is the average distance between the Earth and the Sun at 93 million miles. So it's 93 million miles times about 33, gets you the 3.16 billion. It was discovered by Clyde Tombaugh from Lowell Observatory up in Flagstaff in 1930. And it's got 5 moons. Now it's in relation to the planet, its largest moon is actually very large. I think it's only maybe half the size of the planet. So they're kind of almost a dual system between the two of them. And then the other 4 moons are considerably smaller. So what we're going to do, and I'm going to let Rick talk to how he found Pluto in his telescope. And here we go.
So you'll see a little green box there and an arrow pointing to a very faint little dot there in the center. And that is tiny little Pluto. So the way I found this was I knew Pluto was up. Actually, last summer was when I took this. And I knew about where it was, but I used a system known as star alignment. So my telescope and the camera attached to it take a picture. The software in the computer processes that image and it looks at the stars in the image, and based on that, it knows where the telescope's pointing and it updates the position in the telescope. And then I can have it do what's called a go-to plus, where I say, okay, I want this object dead center in the image. And so the computer and the telescope took a series of pictures and evaluated the frame until it knew it had what I wanted, which is Pluto right in the dead center. Even there, it's a very dim object, and it was hard for me to tell exactly where it was. So I drew this little green box to center in, and I took it into a piece of software, and I drew absolute lines bisecting the top to bottom, left to right, to zero in on it. And then I used a star chart for that evening to locate some of these brighter stars around it and get myself lined up to see, yes, that was Pluto that I had absolutely there in the dead center. So it is a challenge, even because my telescope, even optically with an eyepiece, it's too dim to see. Our telescopes generally can't see more than about magnitude 9 or 10. You need a very large telescope to see a magnitude 14 object with your naked eye. So it takes a camera to be able to do a long exposure in order to see something this dim.
Yeah, and chances are when Clyde Tombaugh discovered it back in 1930, Pluto was probably almost as close, it was still fairly close to in on its orbit. So that helped. And then what he did is he used what was called a blink comparator. And so back then they didn't have computers. So he took a picture of the area that he thought Pluto was in. And then 3 or 4 days later or a week later, he'd go back and take another picture. And then he'd just have to manually scan back and forth between those 2 pictures and see if he could find a little dot that moved. And that's how he basically discovered Pluto. Nowadays, you've got computerized telescopes that can just monitor and scan the night sky pretty easily.
Jim, what was the size of that telescope up at Lowell that they used for the discovery? Do you remember? That wasn't a 40, I don't think.
No, I think it's their Clark telescope. And I want to say it's a 23 or 24 inch refractor.
So even with a refractor of that size and film cameras of that day, the image was still very faint, like it is here in Rick's image. So that's right. How much astronomy has gained over those years to be able to amateurs can now do what professionals were cutting edge at that time.
Yeah, absolutely. So if you go to Lowell's website, which is just, I think it's lowell.edu or lowell.org, just search for Lowell Observatory. And the Clark telescope that he used, I'm pretty sure is the Clark, is still in use. It's one of their outreach telescopes that you can go and look through once we get over with this COVID thing and can get back into doing in-person stuff. Okay,
Yep.
so now we're gonna take a look at the fourth planet from the sun. This is our next door neighbor further out from the sun. And it's one of the celestial bodies that we've sent a lot of stuff to. We've got rovers, landers, orbiters, all kinds of stuff, and they expect to probably have people on there sometime in the next maybe 10 to 15 years or sooner. So any of you youngsters out there, you're coming into what's really an exciting time to be an astronomer or an astronaut, because we're going to be doing a lot of stuff. So Mars is about half the size of Earth. So it's considerably smaller, and the day is just slightly longer by about 35, 36 minutes or so. But the year is much longer. All right, we take 365 years to go around the sun. Mars takes about 687 years. So the year is much, much longer. It's red due to the iron oxide, or what we would call rust here on Earth. And it does have two moons. Phobos and Deimos are the two moons. And like I said, it's kind of one of the most explored planets that we've visited right now. In fact, we have a new rover on its way to Mars right now called Perseverance. Perseverance was launched on July 30th. So it'll take 8 to 9 months to get there. It has a huge, what's kind of like the Grand Canyon. It's called Valles Marineris, and it's about 10 times larger than the Grand Canyon. So it's huge. So what we're going to do now is, Jim, you can go ahead and share your screen, and we'll take a look at what Jim has in the telescope.
What we see there is a 320 power view of Mars through some rather turbulent upper atmosphere again. You can see the shadows on there of the artifacts that are on the surface. That there have been a lot of good pictures taken of it. The two moons, Deimos and Phobos, are captured asteroids. They aren't natural to the formation of Mars, and they translate from Greek as panic and fear, because for the Greeks, that planet name was Ares, A-R-E-S, and also the god of war. Roman and Greek mythology share the same legends about the planets, they just have different names. So that in 1929, it was decided they'd use the Roman names for the planets. Well, that planet in Greek was named Eris, with his two sons, Deimos and Phobos, causing mischief all over the universe. We miss a little bit by not using that name Eris anymore, because if you ever see the constellation Scorpius and you see the heart of the scorpion, or Antares, the star, that came out of Greek mythology as the opposite of Eris, because the reason it was red was the spirits of warriors killed in battle caused by the god Eris. So it's kind of interesting. We kind of lost track of that little definition. But that's Mars, and it is significantly older than Mercury, Venus, and Earth because of the actions of Jupiter as it was moving out to its current position. It caused the destruction of a lot of planets, 20 to 30 planets that were on the inside of Mars's orbit. And Mars just stayed there. It was far enough out that it wasn't affected.
Yeah, and as I mentioned earlier, Mars is just coming into opposition. It'll be in opposition October 13th. So if you get an opportunity to look through a telescope, definitely do that. You could even try some binoculars and see if you can see any, or a spotting scope, and see if you can see any of the surface features. Unfortunately, right now, our seating here in Tucson is just struggling with Jim's 10-inch light bucket, and it's just not coming in nice and clear for us. But we'll see if we can get some better views.
And as you can see, Mars is fairly large in our telescope view. That's because right now it's the closest that it's going to be for many, many, many years. Mars gets the closest, what, about every year and a half? And right now is when it gets its closest to us. So now is the time when all amateur astronomers are out there trying to take images of Mars. And as you can see on the image here, there is some definite surface features on the surface. The large feature that you see right towards the bottom, that's probably the most obvious to you, is called Sirius Major. And the structures just above it are Mare, Mare Cimmerium, and another Mare called Tahinum. And I apologize if I don't get the pronunciations quite right. Now, the polar cap is usually visible as well, but unfortunately, the polar cap has melted down and shrunk to the point where it's almost invisible, but it would be right here on the right side if we could see it.
As Bernie was saying, it is the closest to Earth right now. It's not going to be this close again until 2035. So it's going to be 15 years before it's this close. So if you have an opportunity to get out and observe Mars, even through a spotting scope or binoculars, do so, because this is kind of a once in a lifetime event. It was closest to Earth on October 6th, and it'll go into opposition, which, like I was talking to at the very beginning when I was showing you the pictures of the solar system, that means it's opposite of Earth from the sun. It'll be in opposition on the 13th. Now we're going to look at some large planets that are not as big as Jupiter and Saturn were. They're a whole lot further away. Neptune is just about as far away as Pluto is right now. It is, let's see, it is 2.7 billion miles away. So if you remember, Pluto was about 3.16. So it's almost as far as Pluto is. Neptune is the last classic or regular planet. Pluto gets into the dwarf planet, and then probably, sometime in the near future, I would be willing to bet we're going to find other large objects out in the Kuiper Belt and maybe even the Oort cloud once we get some of these more powerful telescopes up. So Neptune is slightly smaller than Uranus, which we'll look at here in just a minute, and it's about 4 times the size of the Earth. So you can put inside of Neptune, you can put about 60 Earths inside the ball of Neptune. And when we look at it on Jim's scope, you'll see a little bit of color to it. And when you look at it visually, if you've got probably at least a 7 or 8 inch telescope or bigger, you can actually pick up a little bluish color when you're looking at Neptune. It is it's the windiest planet in our solar system. The winds average about 1,200 miles per hour. So that's fast. It's got a very short day. It orbits in about 16 hours. And it's got 14 moons. So most of those are probably captured Kuiper Belt objects or things like that that have drifted too close to Neptune. And actually, and I didn't mention this earlier, but actually all the 4 large planets have rings as well. The only one we can see through most telescopes is Saturn. But through some of the professional telescopes, and certainly in the professional cameras, you can actually see the faint rings around Neptune and Uranus and Jupiter as well. The blue color kind of comes from from the methane that's in the atmosphere. So that's why it looks blue to us. It is not visible to the naked eye. It's got a very long year orbit. So it takes about 165 years to go once around the sun. So it does not move very fast. That is, like I said, that is the furthest planet from regular planet from our sun. So now what we're going to do is Jim's going to show us what it looks like in his telescope. Now remember, he's got a 10-inch telescope, so it's a pretty good size amateur telescope. Now there are much bigger ones, but there's also much smaller ones. The bigger the telescope, the more light it can gather. I didn't really show you here, but Neptune is kind of hanging out in Aquarius, which is the water bearer. You can see him holding a jar and splashing water down. So Neptune's very close, kind of in between Aquarius and Pisces.
All right. In the center of the screen is a dim blue object, and it will start flickering a little bit, and it's a function of the electronics that it's some of the flicker happens separate from other parts of the little object, but it actually is a tiny blue ball from where we are. Jim was talking about we have been talking about these gas giants as being called ice giants. At the core of the gas giants, because of the intensity of the gravity of their size, the pressure is so high that even though the temperature is hot, it still forms a form of ice. It's actually a metallic form of the gas. So they're very icy. And the other part, the other interesting thing is their outer surfaces are colder than 100 degrees Fahrenheit, minus 100 degrees Fahrenheit. So that makes it a very cold place also. And although we know Neptune can fit a lot of Earths in it, so it's a big object and has somewhat a lot of gravity, if you were at the center, if you found a way to stand on the outer surface of Neptune, you would only feel 1.1 times the Earth's gravity. So that's the only one of those big giants you could actually stand on if you found a way to survive falling through the gas. So this is a very unusual planet. Neptune was always said to have been discovered in 1846, but really Galileo discovered it. He just didn't realize it. And it was having a conjunction with Jupiter at the time. It was real close to Jupiter, and he just identified it as a field star. It wasn't until around 1821 when a mathematician was trying to plot the orbit of Uranus, and they found out that the orbital plot didn't match Newton's laws of physics, that they said something else bigger is out there. And some of them remembered Galileo had seen something back when he was looking through his telescope 200 years earlier. So they started looking, but they knew by the deformation of Neptune's orbit about where it should be. And when they looked up there and looked in the right spots, they found it. Two astronomers, Gaia and Lavernier, they predicted where it would be, and they found it where they predicted it, right in Capricorn, near the boundary between Capricorn and Aries. They found it in 1846. In 1821, the mathematical solution for where it should be was published by a cartographer, but nobody paid any attention to him. It was going to be another object out there. It wasn't until 1846 that they found it where they predicted it would be. So that one was the last of the major planets that was found, and the only one whose position was predicted before it was found.
Neptune is the furthest planet from the sun. And Neptune is a star-like object. It's very faint. Usually it's very difficult to pull up on a telescope, mainly because it's so small that it doesn't show much of a disk. And if you look on the screen, dead center, you'll notice there's what appears to be just a bright star. That's the planet Neptune. And it has a very small disk in comparison to the stars around it. These are stars that are in the same field as the planet. Now, you'll notice right above the planet, there's a small little point of light. That is Neptune's moon, Triton. Triton is one of the largest moons in the solar system. And it's very, very, very cold because it's so far away. Triton was the last object to be looked at and photographed by the Voyager 2 spacecraft way back in 1989. I was alive back then, and I was glued to the TV watching the images come in. Triton turned out to be quite a surprise because what they thought would be a cold, dead, uninteresting moon turned out to have quite a few surprises to it. Amongst other things, it had nitrogen geysers that were exploding nitrogen out into the off the moon's surface. So Triton was quite a surprise when they flew by it, and that was many, many years ago. So now I've reduced the exposure time down. You can't see the Triton any longer, but you can see the blue of the planet itself. And that is due to all the methane in the atmosphere of Neptune. Okay, now we're going to move over to the planet Uranus. So currently we're on Neptune. Neptune is the one in the middle of the screen. So I'm in the process of plugging in the coordinates for Uranus. And now I'm going to be telling the telescope to slew over to Uranus. So what you'll notice on the screen here is it'll go blank for a little while here as the camera, the mount moves over to that area of the sky. You occasionally maybe see some objects go flying through the image as it settles in on the field where we're hoping to find Uranus. And by golly, I think that might be it in the upper right corner there. So let's see if we can tweak that over and bring that into our field, and so we can see that a little better. And it has the right appearance for Uranus. I think we've got a winner here, guys. Just trying to bring it over into the middle of the field a little better. Okay, now that that's steadied down a little bit, let's see if we can zoom in a little bit. And I think we've got a good opportunity here. Now I'm going to bring the exposure time down, and that should give us more of a blue dot. Yep, there it is. I think that's definitely Uranus. It has the bluish cast that Uranus has, very similar to Neptune because of its methane atmosphere, but it tends to be a little more pale of a blue, not a deep blue like Neptune is. Okay, the next thing I'd like to try doing is showing some of the moons of Uranus. So I'm going to bring up the exposure time and overexpose the planet, but I'm hoping that some of the moons will pop out. Okay, there are, looks like 4 of the moons. You see it, one down here, a couple near the body of the planet, and then one over here. Those look like very good possibilities for 4 of the moons of Uranus. Now I do have an image. So let's see if we can spot them. Okay, so Oberon is Umbriel and Titania. So let's go back to our image. This is an image taken out of Stellarium. This is not a real view. This is a picture. So this is the real view. And here's the one that's further away. Here's the 2 that are closer, and here's the one that's less distant. So going back, that would be Oberon, the one that's furthest away. Titania, the second furthest away. So this would be Oberon and Titania. And then these 2 would be Ariel and Umbriel. So going back here, Ariel and Umbriel. So those are 4 of the many moons of Uranus, but the 4 brightest ones. And by the way, I marked on here what their visual magnitude is. These are magnitude between 14 and 15. And Jim talked earlier about magnitude scale. Magnitude 14 and 15 is very, very, very dim. Going back, you'll notice this is the dimmest one, and that was the one that was rated at magnitude 15.
All right, good, Bernie. Yes, that was a great view of Uranus and some of its moons. Like I said, Neptune is the furthest planet out. Uranus is the next one in, and it's about 1.8 billion miles away from us. So it's way out there. And to be able to see some of those moons is just fabulous.
I was going to say the moons of Uranus are named after people in Shakespearean plays. I wasn't aware of that. A friend of mine back down in Tucson pointed that out to me. I don't know which plays those would be, but someone more involved with Shakespeare would probably recognize what plays these names came from. Miranda as well, but Miranda is magnitude 16 and much closer to the surface of the planet. So I don't think we've got any chance at all of picking that one up.
All right, very good. So what we're going to do now, I'm going to show you, we're doing this one a little bit out of sequence, but that's okay. I'm going to show you the planetarium view so that you can kind of see where Uranus is in the night sky. Okay, so this is where we're looking at Uranus. Now, Uranus is pretty low in the night sky. So, and it's right at naked eye visibility, but chances are pretty slim that you're going to be able to see it, even from a dark site, that you'll be able to see it with just your eye. But you could probably pick it up if you knew where you were looking and could star hop to it. You probably could pick it up with maybe a pair of binoculars or a spotting scope, but it's pretty, it's going to be pretty tough. Uranus is sometimes called the sideways planet because something really bad happened to it in its youth and it got kicked over on its side. And so it actually rotates on its side. It was the first planet discovered using a telescope. It is slightly larger than Neptune. Now, both Neptune and Uranus, you can put about 4 Earths across the equator of the planet, and about 60 to 65 Earths inside the sphere of Uranus. So it's still pretty good size. It's just really far away. Like I said, it's about 1.8 billion miles away, so it's way out there. So it is closer than Neptune, but much further than Saturn. So when we're looking at the light in Bernie's telescope, you are looking back in time 157 minutes. So at the speed of light, it takes the light that's being reflected from the sun from Uranus to get to our eyeballs. It takes 157 minutes at the speed of light. It has a fairly short day. It's 17 hours, so it's shorter than Earth's, but it has a long year. It takes 84 Earth years to go around the sun, so it doesn't move very fast. It's also called an ice giant. We talked about that earlier. The rings, it has rings. It's got 13 known rings, but they're really too faint to see in amateur telescopes. Maybe some of the big professional ones, and certainly some of the ones that we have out in space are pretty good. Could probably pick them up. It's primarily made of water, methane, and ammonia, but it does have a small rocky center. So it's right at magnitude 6, which is kind of the naked eye limit, but you'd have to have some really phenomenal skies and good eyesight to be able to pick it up, and be able to star hop right to it. So that is Uranus. You guys got anything else to add in?
Yeah, Jim, I got a few things I'd like to throw in there. First of all, Jim just mentioned about the near naked eye visibility. The Greeks knew about Uranus. It was magnitude 5.5 when it would get in opposition, when it would approach Earth at its closest approaches. And so if you're above about 3,000 or 4,000 feet altitude, it's not hard to see it at all if you have moderately good vision. Remember, back around the times of the Greeks, they didn't have a lot of laser surgery or other corrective lenses or things they could use, but it was naked eye visible. But they didn't think it was anything important. It wasn't moving very much detectably, so they just never paid much attention to it. It sat there like that, being up there and visible at the right times until about 1781. And here's the story of how it was found. It was found by an orchestra conductor. And we call him, or his name was Friedrich Wilhelm Herschel, but he anglicized his name to Frederick William Herschel. When he was only 19 years old, he was in a Austrian military band. And at the time, and this was in the 1750s, at the time he was in that band, they were united, or Austria and England were tied together because of marriage. So that if you were you didn't need a passport to travel to each other. In fact, that band, the band of Hanover in Austria, when that orchestra toured England, it was sort of like in the United States, the USO tour. And Herschel fell in love with it. And as soon as he got back to Hanover, he resigned from the army, from being in the military band. Now, his whole family were great musicians at the time. And he went back to England and tried to be a musician there. For many years, over 20 years, he was traveling around trying to get a job as a musician. He was a very good musician in about 8 different instruments, and he was also a composer. Well, back in that time, what you wanted to do, if you wanted to have what would be called a world-class city, in our era, we'd say you're a major league city if you got a major league sports team. Back in that era, you were a big deal if you had your own orchestra. And so he was hooked onto by the city of Bath. The city of Bath wanted him to be the program director for their orchestra. So he did that job for about 10 or 15 years, and they finally decided that he could become the conductor. And so he was a composer. He actually composed 21 symphonies, and he was also the conductor. Very unusual at that time. Bach, Brahms, Beethoven, those guys, they composed, they didn't conduct. But Herschel was a bit unusual. He did both. And he got to talking to a friend of his who was a mathematician and liked music. And he said that, well, you know, the chords that we know about are only because we've experimented with them. But I've heard through my astronomical friends that if you carve your mirror in the right shape, you can get lines, and we call that the Airy disk right nowadays on optics. You can get lines that are unusually related to each other, and you may come up with new musical abilities. So he started grinding his own mirrors. And in his garden one day, he used to test his mirrors out in the garden to see how well he had done them. And his sixth mirror, he was looking out in his backyard, had built it into a telescope, and he was looking in Taurus. And it was 1781, and he used to look for about a week to see if he could detect anything, and he saw something move that shouldn't. So he immediately contacted the Royal Astronomical Society and an astronomer named Charles Messier, who hunted comets in France, and said he thought he'd found a comet. And both organizations said, no, you've discovered a planet and you can name it. So our orchestra conductor liked England so much, he called it Georgium Sidus, or Sidus. That meant King George's sidereal object, because King George III was the king at the time. So because of that, the king thought he was going to be a great astronomer. He actually gave him property on Buckingham Palace that he could build an observatory. Gradually, he drifted away from music, brought his sister Caroline Herschel over from Hanover to be originally to be a singer. She was correcting all his math. And so he paid for her to go to Oxford. And for about 15 or 20 years, she was the world's most highly educated mathematician. And she used to correct his math all the time on his stellar observations. Later on, those of us who are astronomers, we know about a catalog called the New General Catalog and the Index Catalog. Those two catalogs were developed and put together from the observations of William Herschel and his son, John. But the mathematics for them, after John worked for many years on this, were actually done by Caroline. She did the math. But William Herschel actually sort of got away from music. They say he composed 21 symphonies and built 450 telescopes. And he eventually had, at the time, the world's largest telescope at Buckingham Palace and discovered a lot of things. And his sister Caroline actually discovered 9 comets on her own. And that's the interesting thing about, be careful what career you got. That might not be the one you stay with. He's known nowadays as a great astronomer, a great observational astronomer. He found Uranus in his backyard in the constellation Taurus, because that's what he was using as a check of the optics on his mirror. But he became famous because of finding the planet, not because of his work.
All right. Well, thanks, Jim. That was an excellent recap and some good history on Herschel and what, like you said, what goes on, behind the scenes, even from the way back when to some of that still happens today. Okay, now what we're going to do is we are going to take a look at our closest celestial neighbor, the moon. That's the only other body, planet, moon that we've been able to land people on. And we'll talk a little bit about that here in just a minute. If hopefully many of you participated in the International Observe the Moon, which was September 26th. There was, I know, a lot of streaming events all over the U.S., and I'm pretty sure they were streaming probably all over the world. So that was really cool. We got to see some good close-up views of the moon, hear some talks about the moon, and things like that. So that was pretty cool. And I think they do that twice a year. They do it once a year for sure, but I think they do it once in the fall and once in the spring. Now, there's some different theories on how the moon was formed, but basically when the Earth was very young, probably just, 100 million years old or less, it was still mostly molten. And what happened is a Mars-sized planet hit the Earth, and the Mars-sized planet was fairly molten as well because everybody was still early on. And when it hit the Earth, a lot of it was absorbed into the Earth, but a lot of it got kicked out into space and picked up an orbit around the Earth. And so we, for a little while, actually had rings around the Earth. We had debris of this collision around the Earth. What happened is eventually that material coalesced into one or two little moonlets. I think the current theory is probably two. And then those two eventually merged into what we see right now as the moon. When the moon was first formed, it was actually only about 15,000 miles away from the Earth. Right now, the moon varies. When it's at its closest, it's about 225,000 miles. When it's at its farthest, it's about 250,000 miles. So it was much closer and really filled up the night sky. And what would have happened then, once the Earth cooled and we actually had water on the surface, the gravity of the moon being that close would have created tidal waves miles high, and they would have washed way inland. So that caused a lot of, stirred things up and things like that, which probably helped life get started. The moon goes through phases, as everybody knows. And so what happens is the moon isn't perfectly aligned with the Earth. It's tilted about 5 degrees above or below the plane, depending upon where it's at in its orbit. So most of the time it's just, on a new moon, most of the time it's just not quite in between us and the sun. But when it goes through the pattern and is right in line between the Earth and the sun on a new moon, that means the moon is right in between us and the sun, then that's when we have a total solar eclipse. And you'll see just a narrow band going across whatever is facing the moon at the time, or the sun. And it's very, very narrow. So what you want to do, and I would highly encourage people to go and see a total solar eclipse. And you really want to get into the zone of totality where you can actually see the total eclipse. I know the U.S. has one coming up in 2024, April 8th, 2024. It'll come in Mexico, go across Texas, and then go out Maine. But there's usually a total solar eclipse someplace on the planet every 12 to 18 months. So you see, there's plenty of opportunity to be able to see a total solar eclipse. Definitely worth doing when you get a chance. All right, so now I'm gonna turn it over to Jim, and he's gonna talk about some of the specific areas on the moon, and we're gonna take a nice close look and exploration of the moon.
When we first look up at the moon and start really noticing what's there, the thing we see are dark patches. The Greeks used to think those were water, and they called them Maria, or seas. What I'm looking at now and trying to show you right now are two of the many Maria on the moon, because they have a story. In the upper left of the screen, up in this area, is Mare Imbrium. That's Greek for the Sea of Rains. And so the Sea of Rains was a very big asteroid hit. So big, it made the biggest lava crater on the moon. And it pushed material up till it got to a wall right here of rock. And it's very tall. Actually, where my mouse is sitting right now is the tallest spot on the side of the moon that faces us. That is Huygens Peak and Huygens Mountain. And it's about 8,000 feet tall above the mean radius of the moon. And next to it is another crater called the Sea of Serenity. That Sea of Serenity is sort of a partner to the Sea of Showers over here, but they have that dividing wall between them. And it's kind of fascinating because it's the tallest ridge of mountains on the moon. It's called Montes Apenninus. So it's the Apennine Mountains. Another interesting thing is I've got my mouse on a dark area here. That's the Hadley area. That was where Apollo 15 landed. And it actually landed on the side of the hill. There was a slope that it landed. It wasn't a very steep slope, but it was still a dangerous place to be. It was inadvertent. They didn't intend to land there, but their navigation put them there. And it turned out to greatly increase the amount of scientific information they were able to get from that. If I move away and look at some of the other Maria on the moon, we can use our own imagination and actually put a picture together. I'm going to look from Sea of Serenity, where I was just looking, and down below it is the Sea of Tranquility. That's important because that's where, and I'm going to put my mouse where Apollo 11, the first manned landing, was. And if I can get it to get right in this area. Apollo 11 landed there. And that was the first humans, Neil Armstrong, Buzz Aldrin, and Michael Collins flew the command module around. And that's where they landed, the Sea of Tranquility. Well, down below the Sea of Tranquility are two more interesting seas. In the right here is the Sea of Fertility, and over here is the Sea of Nectar. In the Sea of Fertility, and I'll give you a second to pause and look to see right where my mouse is, there are two small craters that have been made there. That was actually a single object that came in and bounced. It came in, bounced, made two craters that are about 11 kilometers across, about 9 miles across each one. And then when it hit the second time, it broke up into pieces, and all the way across here is a ray of debris that was left on the top of the cooled lava when it came down. And if I look over to the right hand part of the picture is the last sea that makes up this tableau. That's the Sea of Crises. So if I actually move the screen over a little bit and bring it down a little bit, and you can actually see this with your naked eye if you look up on the moon, on the upper right corner of the moon. It'll look like an eyebrow up there. It's not moving very fast right now. There he is. That right there in that shape is the lunar poodle. There's his pom-pom tail that's made in the circle, and his upper body has been shaved and cut for a show. So that's kind of an interesting thing there in the moon. But I'm going to see if there's anything else we can take a peek at. And what I will do is move this around. There we go. And now look at Sea of Serenity. Move the mouse. The Sea of Serenity and Sea of Tranquility kind of make a hairstyle. And if I look over to the side, I've actually got an eye socket, and I've got a chin, and I've got, I'm sorry, that's a mouth, and a chin, and a nose over here. That is a lady in the moon. And there is a brooch around her neck, that crater right there. So that's kind of two of the interesting things on the moon. The last thing I'd like to talk about on them is that if I go back up to the Sea of Showers and attach it, imagine that's the body of a rabbit. And if I move this way and down, what was the Sea of Serenity to us is actually the head of the jade rabbit for the Chinese. And if I go further down, there's his ears. He is staying up there to guard the moon for Chang'e, lunar goddess for the Chinese culture. Even in communist China, it's a national holiday. September the 15th is the goddess's day because we are just leaving the harvest time. So she is the goddess of the harvest. The jade rabbit protects what's up there, and the Chinese use that to name some articles in their space program. So far, they have sent 4 probes to the to the moon. The first one was just an orbiter. The second and third, and that was Chang'e 1. Chang'e 2 and 3 landed on the moon and did some roving and sample and gathering and measurement. And then on the backside, Chang'e 4 was the big accomplishment, the first time humans had landed anything on the reverse of the moon. Chang'e 4 became known for its subparts. The actual station that landed on the moon was called U2, after the jade rabbit. Chang'e was the rover that went out to dig up samples. And this was in 2019 when this landed, in January of 2019. And it needed a way to get the signal back to the Earth, so there's a satellite at a neutral gravity position out there that can see both the Earth and the moon. And so it's called Quiquo, and that's named after a bridge of magpies that allow two lovers in the Milky Way to cross the Milky Way and see each other one day or one night a year. And that's the magpies build Quiquo, the bridge that they use. So those parts, the bridge that the bridge for the two lovers to talk to each other, to see each other one night a year, and that's a relay satellite to the Earth. Chang'e, the lunar goddess, that's the name of the rovers. And U2, that jade rabbit, he is the one who stays back and waits for Chang'e to come back. What we've got up in the upper right corner here was what I talked about as being the lunar poodle. And here we've got the hair, the eyes, the nose, the mouth, and chin of the lady in the moon. Over in here, we've got Tycho. That is a tremendous ray crater. It's named after Tycho Brahe, scientist who didn't have a telescope, but still did some of the best observational astronomy in the 1500s into 1602. And if we look over underneath Tycho, if you have a good set of binoculars or a telescope, you can look down in here at the right times. It depends on how the moon wobbles. You can see a crater called Clavius that has a broken up wannabe planet that's got 5 craters across the middle of the base of it. And that is a very fascinating crater. It's the second largest crater on the moon.
Okay, so that was a good overview and close-up view of the moon. Another interesting, Jim kind of talked a little bit about this, but here are where the Apollo landing sites were in relation to the lunar poodle. Again, you can see the whole poodle right in here. Here's the head, the body, the legs coming down here, and then the little fluff ball tail back here. So that's the lunar poodle. 11 was down here in his belly button and 17 up in his neck. And then 15 and 16 were over in that area, and 12 and 14 there. Let's see. Now, Jim talked a little bit about Chang'e 4 that landed on the back side of the moon. If you look at this, you can see clearly that the front side that we see, which has lots of Maury and highlands, totally different than the back side. It kind of looks like a pot marked, looks like a golf ball. And it's a lot darker, a lot of craters. The reason we can't see the back side of the moon is that the moon orbits the Earth at the exact same rate that it rotates. So it's always turning so that its face stays closest to towards us. And so that does not allow us to be able to see the back side at all. All right, so that's a little bit on the moon. I think that's pretty much everything. Bernie, do you have anything you want to add in?
Yeah, if you don't mind going back to that image where the Apollo sites were, Jim. Yeah, that one there, thank you. So doing a lot of start parties, we get a lot of questions about the Apollo landing sites, and a couple of things I'd like to add there. You'll notice there's no Apollo 13. Apollo 13 was the one that had problems with their spacecraft on the way out, so they weren't able to land. They had to come back. They did a flip around the moon and then returned. Of course, there was a very famous movie made of that Apollo 13 disaster, almost disaster. They narrowly made it back, but they did. It was very fortunate of them. So if you assume the 6 successful landings, there was 6 astronauts or 2 astronauts in each landing. So there were 12 men that landed on the moon. Altogether, they were all Americans. Apollo 11 landed in 1969 and Apollo 17 in 1972. And that was the last time that anyone has walked on the surface of the moon. And it surprised some people the other day when they asked where the Russians landed. And I said, no, the Russians never landed on the moon. So every now and then we get some questions about other moon landings, but the Americans were the only ones so far to have walked on the moon. And hopefully in the next few years, we'll have some other countries be able to pull that up. Looks like China will probably be the first one. Thank you, Jim.
All right, excellent. So yeah, that's our nice, good look at our closest celestial neighbor, the moon. So we hope you guys enjoyed our little tour of the solar system. It's not very often that we have the opportunity to be able to hit so many planets in one evening. You know, if you're outside, look down, you got Earth, you got all the ones that we did tonight. And the only ones we weren't able to do were Mercury and Venus. So that's really cool. And I'm glad we were able to focus in on Mars opposition coming up next week and Uranus at the end of the month. It'll be on Halloween, so happy Halloween. So here's just kind of a summary slide of what we had for equipment. We had Jim O'Connor's equipment and Bernie's. And then, like I said earlier, the planetarium program we had was called Stellarium. So you can download that at stellarium.org. Observing locations, we're here in Tucson and Minnesota. And you had me and Rick as narrators and Jim and Bernie as scope operators and narrators as well. Some of our upcoming events, if you're in the Tucson area next weekend, so a week from, well, it'll be October 17th, we're going to be out at the Chiricahua National Monument. We're not going to have any telescopes, but Jim's going to be out there giving a little laser walk around the night sky and talk a little about star lore and native lore and things like that. So we'll have an opportunity to kind of spread out. The parking's a little bit limited, so I would recommend getting there early. We're planning to start, you know, around 7, but it probably, whenever it gets dark enough to where you can start seeing things, but not before 7. We are doing a virtual star party again on October 24th in conjunction with the Lunar and Planetary Laboratory here in Tucson. It's going to be kind of the same thing we did tonight, but it will be live, assuming we have the weather. And it'll be focused on the solar system. So we're going to bounce around the planets like we did tonight. Our next virtual star party is December 5th, 7 p.m. Arizona time. We're back on Mountain Standard Time. So before we were, you know, this month we're Pacific Daylight Time. So in December, we'll be back to Mountain Time Zone. And that'll be starting at 7 p.m. And then after the first of the year, we do have some local stuff starting in January. It just kind of depends on what the status of the pandemic is. I kind of expect those to cancel if they don't have vaccinations out and that kind of stuff yet, but we'll leave that up to Pima County. So just kind of watch our events page on our website if necessary. And then the next virtual star party after that will be February 12th at 7 p.m. And we're going to try to, even next year, we're going to try to do these quarterly. And so, because we can reach out and, you know, bring in a lot larger audience than here in Tucson. But we do plan, hopefully, to get back into doing some real-time stuff in person. Here's just a little bit information about the club. Our dues are minimal, so even if you're not in Tucson and you want to enjoy some of this kind of stuff or support us, we certainly appreciate it. You can just go to our website and donate there. But if you are local or around the Southern Arizona one, we have a lot of really cool stuff to do within the club. We have, you know, 2 dark sky observing places. We have some special interest groups. We have a beginners one, we have an astro imaging, we have a starry messenger. So those are all kind of cool. We have telescopes that we'll loan out, and so you can borrow telescopes if you're a club member. And we have a library that will get you stuff like that. You already know where our Facebook and YouTube channel are, but there's the information again. So we'll kind of summarize up. I'll kind of pass it around the horn and see if any of the astronomers want to put in anything. But again, we hope you enjoyed our little project here. We really enjoy doing the star parties. They're a lot of fun. It's more fun when you can interact with people in person and that kind of stuff. But being able to share this stuff virtually is great. And like I said earlier, this one we recorded because we just weren't real sure how the weather was going to act for us. But the December 5th one we're going to try to do live, so we'll be able to do a few objects and then maybe even have you guys request a few from the astronomer.
As far as the night sky, it's a totally different place to be than the daytime, and there's a lot that can come to you from looking up at it. Just think of all the cultures around the world that use that sky. The things we've been talking about in this presentation of planets, so important to the South American and the Central American and Southwestern Native American cultures to do their planting and to do their cultural exercises. And there are other stories that can be made up from them, but there is no one right answer. Look up, see what you like to see, make up a story of your own, and share it with someone. But the important thing is to get out there, look out, and keep the sky dark. And with that, you can enjoy whatever you look at up there.
All right, thanks, Jim. How about you, Rick?
Yeah, I just wanted to point out to everybody, although we might have made this look easy tonight, having all these planets lined up for us in a nice row. This doesn't happen all the time. All these 6 planets aren't always up in the sky at the same time like this. So this is kind of remarkable to be able to do this. And also point out to everybody, of one of the planets we weren't able to see tonight was Venus. But if you go out in your early morning hours before the sun comes up, you will see Venus rising shortly before the sun does.
Yeah, good point. And Venus a lot of times is referred to as either the morning star or evening star, even though it's not a star, but it's the brightest object, and it almost brings on a 3-dimensional look when you see it. Okay, thanks, Rick. Bernie?
Well, from the frozen cold north, getting close to that anyway. We had a freeze the other night, so my plants are starting to die, but thank you for coming. We've enjoyed your company, and make sure you get out there and look at Mars. Now is the time.
Yeah, absolutely. And again, thanks everybody. And like everybody said, keep looking up. Until next time.